All right, kiddos, this is for now, the last of our differentiation rules, and it's called the chain rule. The chain rule is a rule that we use when we differentiate a composition of two functions, or two functions composed. Now, we write that f of g of x. So g is our inner function, right? That's our inner function, and f is our outer function, okay? So let's first talk about what that means, okay, because it might have been a while. What this means is x first goes through g, right? So if that's a little function box, that's g, and then it comes out as g of x, right? So there's your inner function. Now, what happens to the g of x is that, in totality, goes into our outer function, f, right? So then f kind of acts upon g of x, and out comes f of g of x, okay? So that's really what it means to compose two functions together. I'll give you some examples. Okay? Here's an example. If I look at the sine of 2x, right? So what happens is x is going to begin by going first through the doubling function, right? So this is the g, the 2 of x, and out comes 2x, right? Then the 2x goes into the sine function, and out comes sine of 2 of x, right? So for example, if you if you put in pi, what happens to pi? Right, so pi is going to get doubled to become 2 pi, and then we're going to take the sine of that 2 pi, and of course sine of 2 pi is 0. All right. So structurally, note that this is the composition of two functions, an outer function and an inner function, okay? So the inner function is that action which is being first performed upon x, right? So what's happening is this x is first being doubled, right? So here is your inner function, right? This guy right here, the 2x is your inner piece, okay? And then the sine kind of acts upon that 2x, right? So that's our outer piece. Okay, so in any event, we have the composition of two functions in this case. Sine of 2x, 2x being our inner function, sine of x being our outer function. Okay, so let's talk calculus for a hot second here. To differentiate a composition of two or more functions, we'll first start with two functions. So we'll call it, sorry about this, it's rather annoying, f of g of x, right? What we first do is we differentiate the outermost action, right? We attack, differentiate the outside piece, and we leave the inside piece intact, all right? And then by the chain rule, we multiply, here this is called our chain step, we multiply by the derivative of our inner function, which our inner function we're calling g, so we're going to multiply by g prime. Okay, so we differentiate f with g intact, and then times the derivative of g. So let's look at that example again of sine of 2x, but now let's take the derivative. Okay, I'm first going to differentiate, understanding that 2x is my inner, and sine of x is my outer. I'm first going to differentiate the outermost layer. I'm going to peel away, I'm going to attack that outside layer. And so the derivative of the sine is cosine. Okay, but I'm going to leave the 2x, the inner function, intact. Okay, so what I've done so far is f prime, the derivative of sine is cosine, with 2x intact, my inner function intact. Okay, so that's f prime, and there's my of g. Okay, and here's your chain step, and I'll write it in red. So we're going to multiply now by the derivative of g. The derivative of g, derivative of 2x is times 2, right? Derivative of 2x being 2. Okay, here's your times g prime. That's called the chain step. All right, and then we could rewrite that, I suppose. Just bring this 2 out front to be 2. The red 2 comes out in front times cosine of the quantity 2x. Okay? So that, therefore, is the derivative of sine of 2x. Let's look at another example. What if I asked you to differentiate How about the quantity 3x plus 2 to the 5th power? Okay. Now again, note we have an inner and an outer function. We have a composition of two functions. So the inner function is this guy right here, 3x plus 2. Okay, there's my inner. The outer is to the 5th. Right, so what the chain rule says is you first peel away, you attack, you differentiate the outer piece, right? So I'm going to differentiate this whole function g to the 5th, right? And that's going to give me, by the power rule, 5 times the inner function to the 4th, right? I just use the power rule. Now times, by the chain rule, the derivative of my inner. And the derivative of my inner is 3, right? And so these two red times 2 in the first case, times 3 in the second case, those are chain steps, times the derivative of the inner. Right, and again, I can rewrite that. The 3 and the 5 turn out to be 15 times the quantity 3x plus 2 to the 4th. Okay. Let's do another one. What about the derivative of, let's try a little bit 1 over this cube root of 5x. Well, the first thing I want to do is I want to rewrite that. So that ends up being, without any calculus, the quantity 5x to the what power? No. Yes, correct, to the negative 1/3. Okay, so that's 5x to the negative 1/3. So again, I have a composition of two functions, the inner function being 5x and the outer function being to the negative 1/3. All right, so the chain rule says, okay, you attack the outermost function first. So the negative 1/3 comes down, you keep the inner function intact, and you bump the power down 1 by the power rule. Okay, and then bam, here comes my chain step. I'm going to multiply by the derivative of my inner, which is 5. Okay, and we can clean that up in the 5 and the negative 1/3 multiply to be this. Bada bing, bada boom. Okay, finally, one more. Last problem. How about the derivative of the sine squared of x? Well, perhaps it might be easier to write it as such. It's the same thing. It's just how we write sine of x, the quantity squared. We just write it like sine squared of x. So now in this form, I think it's much easier to see what's our inner function and what's our outer function, right? And so I'm going to use the chain rule. The 2 comes down. I'm going to peel away x squared first, but it's not an x squared. It's sine of x, the quantity squared. So down comes a 2. Keep the sine of x intact. Bump the power down 1, so it becomes to the 1st. Times, now by the chain step, the derivative of my inner function. The derivative of my sine function is cosine. Bam. Okay, and that happens to be a nice little identity. We'll leave it as such. Okay, so that's the chain rule. This is the last of the rules we're going to present for now, and come to class tomorrow ready for a open notebook quiz on the chain rule. Bye bye.